This is Rges Pre-Algebra, Lesson 1.14, Adding Fractions. It's easy to see from a pictorial standpoint that if I were to try to add fractions, and I'm saying I want to add 3/4 plus 2/3. Well, so here I would have 3/4, and here I would have 2/3, and that's very difficult to add together, very difficult to see what I would come up with. But if instead I divided this into the same number of parts in each pie, so to speak, or in each circle, if I divided both of them into the same number of parts, then it would be very easy to count up the shaded number of parts. That's what we're talking about when we're adding fractions. So it's essential that we have the same common denominator, or a common denominator, the same denominator for both of these. Now you know how to figure out what is the same denominator. Okay. Remember, the same common denominator would be the same as the least common multiple. If I have 4 and I have 3, what is the first number that both of these divide into evenly? Well, recall that we could either say 4 equals, count up by 4s, 4, 8, 12, 16, etc. 3, count up by 3s, 3, 6, 9, 12. And the common one would be 12. Or we have our second choice, where we could do what? Make the 4 into primes, 2 times 2. The 3 is already a prime, so there's no changing there. And I'm asking myself for each prime number, the least common multiple, which is what we're going to use for the common denominator, would be the largest number of 2's in any one. That would be 2 of them. That's supposed to be a 2. And the largest number of 3's in any one. Multiplying it together, I get 12. Okay. Now, sometimes for these simple numbers, I could just know that. I know that the first number that I'm going to come up with a 3 and a 4 going evenly into would be 12. And the more you work with fractions, the more many of these will be obvious without going through all that exercise down below. But this needs to be some number of 12s. And this needs to be some number of 12s. Well, how would I convert 2/3 into 12s? I have to ask myself, what number did I have to multiply by 3 to get 12? And the answer was 4. Is 4. I'd have to multiply 3 by 4 equals 12. Well, if I do it on the bottom, I also have to do it on the top. So 2 times 4 is 8. So 2/3 is the same as 8/12. Up above here, what number do you have to multiply by 4 to get 12? And the answer is 3. If I do it to the denominator, I better do it to the numerator, so I have an equivalent fraction, and 3 times 3 is 9. Now, between these two, it becomes a very simple process to add them together. You always keep the same denominator. Think back to your picture of circles. I'm not changing the number of parts I'm dividing it into. Okay, I figure out a number that would divide, that would work for both of those sections, so the denominator will remain the same. I simply add my numerators. 9 plus 8 is 17/12, and that's my answer. Now, if they ask you to convert that then to, and it is improper, so if I wanted to convert that to mixed, I would say 12 goes into 17 one time, recalling this from the last lesson, with a remainder of 5. And 5/12 is a simplified or reduced part of the fraction, so that is my answer. Now, let me go over a couple more. This next problem, what I have mixed numbers. Notice they've been very nice to me. They've given me all of these already with a common denominator. So the fractional, I first could add up the whole part. Okay. that would be 11, 13. And then adding up my numerators for my fractional part, I get 9/8. Now notice 9/8 is improper. So I need to convert that part to 1 1/8. So my whole number, and I combine that with the whole part I've already got, would be 14 1/8. So hopefully you see that. What have I done? I've added up the whole numbers. I've added up the fractional part. And if needed, I've converted the fractional to a mixed if it's improper. And then add the whole to the fraction. All right? Or really, I want to say add the whole that I got up here in the first part to the mixed that I got here to get the complete answer. Let me show you another example of something that could happen. Here I also am adding mixed numbers, but notice they do not have a common denominator. So I'm going to convert my my fractional part to common denominators. I have 6, 3, and 9 as my denominators. 6 is 2 times 3. 3 is prime, so it's just 3. And 9 is 3 times 3. Remember to get the common denominator, which is the same as the least common multiple. I'm asking how many 2's do I have? What's the greatest number of 2's I have in any one? And that would be 2. What's the greatest number of 3's I have in any one? And that would be 3 times 3. And that would be 18. So that's my common denominator. So let's convert each of these, just the fractional part. Okay. 6 times what is 18? The answer is 3. I'm multiplying it in the denominator and also in the numerator. 3 times 1 is 3. 3 times what is 18? That would be a 6. Don't forget you have to do it in the numerator also. 2 times 6 is 12. 9 times what is 18? 2. I have to do it in the numerator also. 4 times 2 is 8. Okay, so that's like the preparatory step, because I can't add these fractions until I've converted them. So now you just want to, oops, sorry, let me pull this down a little. I want to add the numerators. That'd be 23, 18. I add the whole numbers. That would be 17. And now again, I have this problem that this is improper. Change it to proper, which is 1, remainder 5, 1 5/18 to be added to my 17 equals 18 and 5/18. If 5/18 could be simplified, I would need to do that, but as it is, it can't be. So that's the end of the addition, and do these problems very carefully. If you take the time to practice them carefully now and understand why you're doing each step, they'll become very easy for you with a little bit of extra practice.